So we are at the midpoint rule. We already know how to solve an integral, but using the Rayman sum. We know that integral a to b, any function dependent on x, is equal to limit n approaching infinity summation I from 1 to n f of xi delta x. So this is the information which we have so far to calculate an integral. And for this information, we have already tried 3 different types of methods. One was using the left endpoints for this thing. Second was using the right endpoints. And the third was using the midpoints. So yesterday we tried to solve a question, and we applied the left endpoints and the right endpoints. But we also have the procedure of following the midpoint rule, and so we can apply the same rule here to find an integral, and we will see that, for example, if R40, I told you for that specific question, R40 was nearly equal to 6.63 something, and L40 was the nearly equal to the same, but the actual answer to that limit was 6.75. And we saw that when we calculated R6 first. When we calculated R6, we got an answer something like minus 3.3 something. So it was because we used less number of subintervals. And when we increased the number of subintervals from 6 to 40, we didn't calculate, I just give you the reference. R40 gives you a better approximation, which is nearly equal to the actual answer. This was happening because of the less number of subintervals. Similar is the case with L40. If you calculate R40 or L40, means right endpoints for the 40 subintervals or left endpoints for the 40 subintervals, the approximated answer is somewhere close to this number. And this number is very much close to this number. But if we apply the midpoint rule, then we can get even much better approximation if we calculate M40, means midpoint rule for the 40 subintervals, the same thing, but for the midpoints. Then we will get nearly 7.3 something like this. So you can see this number is very close to the actual number as compared to this number. So R40, L40, they are good for approximation if we increase the number of intervals, but M, the midpoint rule, is much better than left or the right points. So we can define the midpoint rule that integral from a to b, the function f of x dx, this is equal to, you know this rule, limit n approaching infinity, summation I from 1 to n, f of xi bar delta x. Now what is xi bar? It is the same xi steric. That time we were using steric, and we said that it is most probably the midpoint, but maybe not the midpoint. In that case, we said if we have the interval xi minus 1 and xi, then we can pick up any number in between these two, and we say this is xi steric. So any number in between them, or the midpoint in between them, can be xi steric. But in this specific case, now we are using the bar which if you go back to the statistics, the bar is always used for the average. So this bar we are using to represent the midpoint, and xi bar means half of the xi minus 1 plus xi. Means if I am saying x1 bar is my midpoint, then what is x1 bar? X1 bar is half of the first point plus second point. Similarly, if I am saying xn bar, then this is half of the 1 less than n number plus the nth term. So this is the rule and the criteria to calculate the integral using the midpoint rule. Let us do an example to see what happens here. Everything is written on the pages, you don't need to calculate. You don't need to write. So we have an example that approximate the integral 1 to 2 1 by x dx using the midpoint rule. So you are bound to use the midpoint, no left, no right. Such that n is equal to 5. So this is enough data which we needed to solve a question using the midpoint rule. How? This point is always a, this point is always b, this guy is f of x, this is delta x, n is known. Now I need the value of delta x, so I can find it. The value of delta x is what? B minus a divided by n. This is the formula for delta x. I have b, I have a, put them here. So it is 2 minus 1 divided by n, which is given. So it is 1 by 5, that is 0.2. Now this is what? This is going to be the width of the subinterval, which I am now going to split this whole domain, this domain. So my big interval is a is 1, b is 2. So this is the big interval. I am going to split this interval into 5 subintervals using this width for each interval. Okay, so I have enough data to go further. Using this data, I have calculated delta x, which is 0.2. Now using that value of delta x, I am going to split this big interval into smaller intervals. The first point x. The first point is 1, it will remain 1. Now the second point is, if this is x naught equals to 1, then the next point will be x naught plus the width of the interval. That is 1 plus the width of the interval, which I have already determined, 2. So it will be 1.2. So the next point will be 1.2. So this is the now first subinterval. Then this will be the first point for the second interval, and 1.2 plus this width again, so it will become 1.4. 1.4 to 1.6. 1.6 to 1.8. 1.8 to 2. So that is the last number, that is the upper limit, so I will stop here. Now I have already got 1, 2, 3, 4, 5 subintervals, that's it. In the case of left end points, I will simply pick up the left points and go on. In the case of right end points, I will simply pick up the right points and go on. But here you are bound to use the midpoint rule. So you are not done here. You have to get the midpoints of each interval. So for the first midpoint, x1 bar, you have to add these two numbers and divide them by 2. So that is 1 by 2 first plus second. That is 2.2 divided by 2. So it will be 1.1. So the midpoint of these two is 1.1. Similarly, if you calculate the midpoint of these two, that will be 1.3, 1.5, 1.7, 1.9. So I have got all the midpoints. These are 1.1, 1.3, 1.5, 1.7, 1.9. So these are the midpoints. This is the delta x. This is the f of x. So I have everything to put them into the Rayman Sum formula. So I can say integral 1 to 2 f of x dx is equal to what? Limit n approaching r. In this case, since we have the definite number of n, so we are not applying the limit. We will say that I from 1 to n, which is in this case 5, f of x bar I delta x. Now, do you know how to solve this? This thing is simply, okay, let me say this is I. So I is equal to, this thing is simply f of x1 bar delta x plus f of x2 bar delta x plus so on. The final is f of x5 bar delta x. You can take delta x outside. So it is f of x1 bar. Means the value of the function at x1 bar. This is x1 bar. This is x2 bar. This is x3 bar. This is x4 bar. This is x5 bar. So the value of function at this number. But what is the function? The function is 1 over x. So it means the value of function at this number. Plus, I have taken delta x common outside from everywhere. So I am now only going to write these values. The function is 1 over x. Wherever there is x, replace it with these numbers. For the first time, replace it with the first number. Second time, replace it with the second number, x2 bar, plus 1 over x3 bar, plus 1 over x4 bar, plus 1 over x5 bar. Now when you add them together and you know the value of delta x, which is 1 by 5 or 0.2. When you calculate, do this calculation, the answer is 0.691908 for this function. Now it was integral using 5 midpoints. Now if you will increase the number of intervals, this answer will keep on changing. If you go up to, let me say 50, then you will nearly go to a very good approximation for the area under the curve of this function for the interval 1 to 2, for this interval. you will get a better approximation if you keep on increasing these number of intervals. So this is the midpoint rule. Now you can apply the same midpoint rule to the question yesterday, for which when you solved it using the right endpoints, you said R6 was something minus 3.32, something like this. We did this. So if we do M6 for the same question yesterday we did, this number will be not the same. It will be better than this number because we are using the midpoint. So the question, the point of interest is that the midpoint rule is always better than the left or the right endpoint rule. Okay. So do you have an answer to my question at the beginning of this lecture? How did you get that answer? My question is still unanswered. How did you get that answer?
We were in our house.
My question is, how did you get 618? Josefa, just tell me the truth.
No, the method I just put that in calculator and just it gave me answer.
How can you put the infinity in calculator? There is no option to put the infinity. Do you have a button of infinity in your calculator?
No, not this one, like on something internet.
Okay, so you just search it online.
Yeah. I put that the data after that step in calculator and it just gave me answer. I thought maybe you don't need those steps, so I just directly did that.
No, I always tell you that my point is not the answer. My point is, how did you reach to this guy? So if you don't know how did you reach there, then everything is meaningless. Okay, let me tell you how did you reach there. The terms were 3 by n into 2062 n 4 plus 3045 n cube plus 1170 n square minus 27 divided by n cube. Now if I take this n inside, so it will become n4. Now the important point here is that if you have an expression, and here you have a limit n approaching infinity, if you have an expression that when you apply the limit to it and the answer is infinity by infinity or 0 by 0, then you are not allowed to apply the limit at this level. You have to go further to eliminate something out of it so that you can get rid of this kind of situation. So here when you put the infinity, the answer is infinity by infinity. So you are not allowed to put the infinity at this stage. So you have to do something further. Now, if you take n4 common from the upper terms, it is limit n approaching infinity 3, and inside I am going to take n common from all the terms. So if I take n raised to the power 4 common from here, it is 2062 plus here it is 3045. Now I don't have n4 here. but I can make it n4 if I at the same time if I multiply and divide this thing with n and n. So I'm doing nothing. It is just a 1, n by n. I replace the 1 with n by n. Now I can keep 1 n with this guy and keep 1 n with this guy. So this one I put here and this one I multiply here. Now it is n4. So you can take this n4 outside. So it becomes 3045 by n, the n cube and the 1n, n4 coming out. Similarly, here you have n square. You can make it n4 simply by multiplying and dividing by n square. So actually you are doing nothing. These are cancel out 1. So this is just a 1. But you can write this lower n square here and this guy multiplies here, so it becomes n4, and I just took it outside as a common, so it is okay. Similarly, minus 27, you don't have any n4 here, but you are taking n4 common from each term, so you have to make an n4 here. How can you make that? Simply multiply and divide that term by n4. So you are doing nothing, but you are taking the advantage of nothing. This n4 you can keep here, and this n4 you already took common outside, so it goes there. Now that's it, and divided by this n4. Now these two guys cancel with each other, so they are finished. Now if you apply the infinity, you will not get the 0 by 0 or infinity by infinity. It will be 3 into, now apply the limit infinity, it will become 2062 plus this number divided by infinity. Any number divided by infinity becomes 0. This number divided by infinity becomes 0. This number divided by infinity becomes 0. So you have 3 into 2062, whatever it is. When you divide this whole guy, there is a 5 also in the, no, below there this was not, it has a 10. This number has 10 here, so we have a 10 here. So when you divide this whole thing with this number 10 also, then your answer is something like this. The question is here that here up to here you cannot apply the limit infinity, but you can do this thing. This is same, both are, these two are same, but here you have the choice to apply the infinity. Do you understand now?
Yes, yes.
So we are gradually moving towards the integrals, and we are already actually into the integrals, and we have some properties to go further. So the first property is, we have named them as n1, n2, and they are something like maybe n10 or 11. So we have 10, 11 properties, and we are going to discuss them one by one. The first property is, if we have integral a to b f of x dx, then it simply means that this is the bigger guy than this. That is, b is always greater than a. But in some cases, if b is less than a, then this formula reverses the order. That is, integral a to b f of x dx becomes negative of integral b to a f of x dx. If this number is smaller and this number is larger, then this whole expression will take this form. So you can switch them by using one negative. So the point is that you can always switch these limits, these points between each other. One time when you will switch them, if you want to move this b here and you want to move this a here, you have to multiply one negative for one time switching these numbers. So every time when you will switch these numbers, you have to add a negative before the integral. So you are not allowed to switch numbers without using this negative sign. You are not allowed to switch AB to BA without having one negative here, without multiplying one negative here. If you do not multiply, it means you are doing something wrong. This is first property which you should keep in mind, that you will always have to keep the limits in the same order. And the rule is that the one sitting here is bigger than the one sitting here. This is the rule. B is always greater than A. Second property. If both of these numbers are same, for example, limit 1 to 1 or limit 2 to 2, means if both A and B are equal, then in that case delta x, which is b minus a divided by n, it becomes, if you say okay, a is equal to b, so if you replace a with b, it becomes b minus b over n. Or if you say b is equal to a and you replace b with a, it becomes a minus a over n. In all cases it is 0. So what does that mean? It simply means, what is an integral? Integral is an area under the curve, and you are interested to know this area. If this is your curve, you are interested to know this area. So what happened? You started from a point, this point, and you reached to a point, this point, corresponding to which this is a f of a, and corresponding to it this is b f of b. Do you know this? Do you know this? What is this? Why I have written this?
What? I don't understand what.
Do you know this? Why corresponding to b at this point I have written this thing? Why? What is this?
It's like the one is p and the other one is the derivative of p, because the other axis is the derivative of
Come on.
that point.
There is no derivative. Come on. If you are sitting here, let's suppose this is any number x, and I'm asking you, now this number is lying on the x-axis, and I'm interested to know the corresponding value in this quadrant, in this region. Then what will be the corresponding value in this region? That will be somewhere here, this number, which is the x quadrant, and the value of the function at this number, the function is f, and the value of the function at this number, that is the y quadrant. So it is actually xy. If I want to, if you are asked to locate a number in the 2 dimensions, this is y, this is x. This is the x-axis. If I ask you, locate me a number on the x-axis, you will simply move like this. And if I ask you, locate me a number on the y, you will simply move like this. But if I ask you, locate me a number in this quadrant, which is the first quadrant of the 2-dimensional Cartesian coordinates, then you will have to figure out the positions of both x and y. So these are actually, this is the position coming from y, this is the position coming from x. This guy gives me the x quadrant, this guy gives me the y quadrant. And what is y quadrant? I know that x is x, but the y quadrant is actually the value of the function at this x. So similar is the case here. You know these things from the very first chapter of advanced mathematics. If this is the point on x-axis, then corresponding to this in the quadrant on the curve, the corresponding point is always written like this. This is the x-axis point, this guy approaching here, and this is what? This is y. This number is x, this is y, and this is coming from the y-axis. This is my y-axis, and when I go from the y-axis to here and from the x-axis to here, the point where these two lines intersect with each other is represented by this ordered pair. And this is the same thing which you already know, that if you have two sets 1, 2, 3 and you multiply them together, then you will get the ordered pairs 1 cross 1, that is 1, 1, 2 cross 2, that is 2, 2, and so on. So what are these? These were the numbers on one axis, maybe on x-axis, and these were the numbers on the other axis. When you multiplied them together, now you are not on the axis lines. Now actually you are moved inside into this region. So these will determine that where are you sitting into this region. A single number can never determine. Anyways, that is another discussion. We are not going there. So the point here is, if a is equal to b, then the integral means if a equals to a, f of x dx, then the answer will be 0. Means both the points, limit points, none of them is greater than the other. If this guy is greater than this guy, then this is a positive. If this guy is greater than this one, then it is a negative integral. But if none of them is greater than from each other, both are equal, then the answer will be 0. And why this answer is 0? Because integral means area under the curve. Now, what curve? A curve starting from this point and reaching at this point. Corresponding to this, a curve corresponding to A and reaching to B. So you have this gap. Now, if you move from A to B, then you will have this curve and you have this shaded region to find the area. If A is equal to B, it means either you are standing at A or you are standing at B, but you are not moving anywhere. So I am asking you that you are standing at A and walk from A to A. What does this mean? It means I am still standing at A. So I am not moving anywhere. So it means I didn't cover any distance for the curve. It means the curve is nowhere. This is just a dot. And you are never be able to calculate a dot, to calculate area under the dot. So you are standing here and I am asking you to give me the area under the curve. In that case, you will say, okay, integral A to A, if I am not moving anywhere, whatever the function is, the answer will be 0. Do you understand?
Yeah.
Property 3. Integral A to B c dx is equal to c into b minus a. Now what does this mean? We know that if we write integral, then there will be an f of x and there will be a dx. So I have a dx here, I have the integral, and this is c, which is a constant. So it means I have a function f of x, but it is a constant function. And you know the definition of a constant function, that whatever the value of x is, the answer will be same. If your constant functions, for example, I am saying f of x is equal to 3. Now whether you put x equal to 0 in this function, the answer will be 3. And if you put x equals to 1000 in this function, the answer will be 3. Whatever you put in place of x, the answer will remain that specific constant c, because this is a constant function. So in that case, your answer is this. Now why or how this answer appears? If you look at the constant function graph, the constant function says something like this. For example, this is the x-axis and we are moving on the x-axis. Okay, let us start from any point A and end at any point B, because here we have A and B. So I'm saying I'm interested to know the behavior of this function, the area under the curve of this function for this distance. So the curve of the function started from here and finishes at here. Now this is C. If I put A, the corresponding value is C. This is a fixed number C, for example 3. Let me say 3. So if I put any value A from the x-axis, the answer is 3. Answer is C. Now let me move here. Now this was A. Okay, if we take them as numbers, that will be much better. If I say this is 1 and this is 3, and the constant C is equal to something like 4. So I am saying that when I put 1 into the function, the answer is this. So it is 1, 4, this point. Now after moving from 1, I am moving here. Let me say here, and when I reach here, okay, say here, I am at number 2. When I put this number 2 into the function, again I get a value corresponding to this point, which is 4. So I put the number 2, but the answer is again 4. You see, when I put 1, the answer is 4 because of the constant function. I put 2, the answer is again 4 because of the constant function. The function is moving on the same line. Similarly, when I reach here, I put 3, the answer is again corresponding to this number, 4. So what is this? This is x, and the second guy is f of x. This is x, the second one is f of x. This is x, the second guy is f of x. So you see, x is changing. Every the point x is changing, but the f of x is same. This is the property of the constant function, that whatever the value of x is, f of x will remain same, corresponding to the same specific value of the y-axis. So now in this case, I am interested to know the area under the curve generated by this constant function, which is like this, going like this, and this is C, a constant function, y is equal to C, f of x equal to y equals to C. Now corresponding to A, corresponding to B, I am interested to know the area under this curve. Now you can see this is exactly a rectangle because of the constant function. So what is the area? The area, I am interested, integral is what? Integral is the area in the shaded region. This is the curve, y equal to C. This is the function, this side. This side is the function, and these are coming from these points. These are of course straight lines, but this straight line is coming because the function was constant. So I finally got a rectangle, and what is the area? Which is integral from A to B for the function y equals to C, for the function C into dx, and this is equal to what? It is area in this region, that is this side into this side. Now this side is what? This side is this distance from here to here, it is C. So it is C, and this side is what? This point is B, this is A, and before a there is something, that is a, the value of a. So if I am interested to only know this side, it simply means this number minus this whole thing. B minus this whole thing. What is this whole thing? This is a. So B minus a. B minus a means only this slot. This number minus this whole thing, you will only get this slot. So C into B minus a, that is what here. So you don't need to calculate if you have a constant function. You can simply write, for example, if I ask you what is the integral 1 to 3 dx, then you can apply this formula. This is C, this is dx, and you have b and a. This is a, this is b. So you can apply this formula, keep this here, C into the b, which is 3, minus a, which is 1. So the answer is 6. Understand? Okay or not okay?
Yes.
How about the left hand point and right hand point? Actually, it's an
Your voice is not clear.
I mean the left hand point and the right hand point actually the same because it's not curved.
Yeah, the formula, this is the simple formula. Integral a to b f of x dx. But I am saying, what is this? This f of x is a variable function, any function involving x. So sometime it is 1 by x, sometime it is x square plus 1, something like this. So everywhere you see x. But I say that if I have a function like this, f of x is equal to 4. Now you can never say this is not a function. You have already studied the types of functions and you started with the constant function. So this is the very first type of the function, that a constant number is also a function. Any number is a function. It is okay. You can say that it is 4x raised to the power 0. So you can see an x, but the power of x is 0. That is why it is not visible. So any number is also a function. So I'm saying, instead of these kind of functions, for these functions the rules are different. If I have this kind of function, that is, if I have a constant number into dx, the formula says simply keep this number here and plug in the limits and find their difference, b minus a. That is your answer. If this is 1 to 3, then 4 into 3 minus 1, that is your answer. You don't need to do any kind of other methods to solve this integral. N4 says, if you have integral like this, a to b, a function f of x plus g of x into dx, then you can always write it as, split it, a to b f of x dx plus integral a to b g of x dx, and then you can solve them separately. You can solve this separately and you can solve this separately. Whatever the answer is, answer 1, this will be answer 2. Simply add them together and you will get the final answer. So if you have a combination of two functions, for example, I say 3x square plus under the root x. So what does this mean? Means I can say this is f of x and this is g of x. So if I ask you that give me an integral of 3x square plus under the root x into dx, so you can first, at the first step, you can split them. You can say, okay, integral the f of x, which is 3x square and the dx, plus integral g of x, which is under the root x, into this dx. Split them. Now solve this separately. Solve this separately using your information, whatever you know the process to solve. And then whatever the answers are, add them together. That is your result. So you can always do this. If you have a combination of 2 functions, 3 functions, 4 functions, split them one by one and then solve. If you want to know this by the area under the region stuff, then let me say that this is the function, the curve for the function f, and suppose there is another function which is giving me a curve like this, and they are finishing here, and I'm saying this is the function g of x and this is the function f of x. These are the 2 curves generated by the functions, 2 functions f of x and g of x, and these are the points a and this is the point b. Then now this thing is written like this: f of x plus g of x and together dx. If you combine this together, this is f of x and g of x separately. This function is separate, this function is separate. But the point of interest is what I am interested to know. I am interested to know the area under the shaded region. So even if you remove this line, still you will get the area under the shaded region for this whole thing. So it means the f of x is already added into g of x. So f of x plus g of x is valid. So separately like this, or add them together like this, both is equal, because the purpose is same, area under this region. Whether you keep the f of x or you remove it, it is coming inside the g of x. These are the basic properties, which some of them you already know, but since we are going towards the Gen 1 integral, so we have to know them first. Similarly, if you have a combination of a constant into a function into dx, then you can simply keep this c outside, just like you did in case of summation. I said if you have c f of x delta x, then you can keep this c outside and you can say this is c summation f of x delta x, because whatever you will do, the n times is always there. So when you will simplify this, that n times will automatically come to this c, so it will become n times this thing into c. The purpose of summation on c is what? When you write summation c, it simply means n times c. Summation I from 1 to n c, what does this mean? It means n times c. Now, even if you keep this outside, if you keep this c here outside, still whatever is left, you will do something on it n times, I from 1 to n. And whatever the answer will be, it will always be n times of something. So n times is still coming to multiply with c. So whether you keep it inside or you take it outside, ultimately you will get something n times. So similar is the case. If you have a function depending on x, but also a constant number, then you no need to keep it inside. You can keep it inside, it's your choice, but you will, that your writing burden will be increased. So you can simply take it outside just as a common and solve the integral on the variable function. Whatever the answer will be, just multiply it with the constant, both are same. You can do, if you don't want to do this, no problem. You can keep the c every time, but that will increase your burden. You have to write more. Both cases, in both way, the answer will be the same. Whether you keep it inside with every term or you just take it common outside and multiply it with the answer. I have written a lot of details on the pages. You should read them later. Similar is the case if you have integral a to b f of x minus g of x into dx, then this is the same integral a to b f of x dx minus integral a to b g of x dx. Now the proof is interesting. The proof is, one thing you should know in logical mathematics, there is no concept of a difference. It is actually, a difference is actually a sum of the negative number, sum of something positive with negative. So if you are writing a minus b, this is generally wrong. Actually this thing is a plus a negative of b. So this is the logical form of this statement. So actually you are adding something negative into a number. So it is negative of b which is added with this term. So when you are adding two terms separately, then you are always adding them, even if it is a minus b, but you are actually adding them. But the problem is the second term has something negative. So there is always addition. The subtraction is just a sub property of addition. So here in this case, you cannot directly split this like this, but actually behind this there is a rule which is coming because of this positive formula which we just wrote before. So I can write it in two short lines. So let me take this guy to prove this, the right hand side. So to prove this, I can say integral a to b, what is this? This is f of x, and I told you if you have a minus b, this is actually a plus negative of b. So if you have f of x minus g of x, this is actually f of x plus negative of g of x into dx. Now consider this whole thing as one function and consider this as two functions, and we have just now written a rule that if you have addition of two functions and they are under the same integral, then you can split them. So you can split these two integrals. You can say a to b, this function into this dx, plus this integral a to b, this function as a whole, which is minus g of x into this dx. Now this is actually integral a to b f of x dx plus, what is this minus? This minus is a to b minus 1 into g of x into dx. Now what is a minus 1? It is a negative number. It is a real number. It is a constant. So you can replace negative 1 with c. So here I am going to replace this negative 1 with c. So I can write it here. This is integral a to b f of x dx plus integral a to b. I am replacing the negative 1 with c, a symbol for the constant, into function g of x dx. Now I know a rule which says that if you have integral c f of x dx, then you can keep this c outside. So you can write it as c integral a to b f of x dx. So f of x, g of x, h of x, all these represent a function. So if you have something, a constant multiplied with a function, just like this, keep this c outside. So it becomes a to b f of x dx plus this constant outside and the integral inside, a to b g of x dx. Now I'm going to come back to the original value of c. What was it? It was minus 1. So it is integral a to b f of x dx plus The value of c is minus 1 integral g of x dx. A plus 1 into minus 1 integral a to b f of x dx minus integral a to b g of x dx. So this is the logical way to write this thing equals to integral f of x dx minus integral g of x dx. You cannot directly write this into this, but actually you will follow that procedure, then you can write it by giving the logic. And in the next semester, most probably you will come to me for the logical arguments in the discrete mathematics. I'm not sure, I don't know yet. So this kind of things we are going to deal with a lot in the discrete mathematics. Okay? Are you sleeping?
No.
You're not sleeping, sir. You're here.
Is it
You're
boring?
here.
Is it boring?
No, Laushi.
Okay, let us do a very simple example of the integrals. Solve the integral 0 to 1 4 plus 3x square dx. So you are going to apply all those properties and 1, 2, 3, whichever is applicable here to solve this integral. So the first step is, I'm saying this is a function f of x and this is a function g of x. So I'm going to use the rule which is written in N4, that if you have sum of two functions, you can split them. So using N4, it will become 0 to 1, which is a to b. First function separately with dx, that is 4 dx, plus integral 0 to 1, second function separately into dx. Now, if you go back, now the second step, if you go back, we had maybe N3 it was, and it said that if you have a constant into dx, a to b, then you can write it as this constant into the b minus a. So here, the same situation, we have a constant 4 into dx. So we can apply this formula here for the first integral. So it becomes this 4 times b, which is 1, minus a, which is 0. So this integral is solved here. Plus, now here the things is still complicated. We have a constant into a function into dx. So this is just like the property which we said that if you have integral a to b c f of x dx, then you can write it as c integral a to b f of x dx. So this is c, a constant number. C and x square is f of x, a function, and dx. So I can apply this formula here. It becomes constant, take it outside, integral same x square dx. Now up till here we are done. This is 4 plus 3 integral 0 to 1 x square dx. Now here we know how to solve this. Can you solve this integral? The remaining integral? This is okay, but we need to solve this integral. And you guys already have done this for me. This is equal to 4 plus 3 times integral 0 to 1 x square dx. I think you have solved it for me. Do you remember? This is equal to 4 plus 3 times. For this, we said that limit n approaches to infinity, summation I from 1 to n xi square into delta x. Remember?
Yes.
And for this,
Yes.
you said you solved it using n intervals and you applied the limit. You used the 1 square plus 2 square plus 3 square formula, and finally you gave me an answer. This is 3 into the answer for this whole thing was 1 by 3. You have solved it. But if I ask you this question in the exam, then you have to do all those calculations. You cannot give me a reference that okay, we have done this in the homework.
Yeah.
So you will solve this by using what you have done in the homework. This is cancelled, so it is 4 plus 1, it is equal to 5. So the answer for the original integral, which was 4 plus 3x square dx. The answer for this whole integral is 5. So far, by using the method of Rayman sum. Can you hear me?
Yes.
So the
Yeah.
property number 7
Yes,
is
yes.
if you have an interval like this, A and B, and in between from this region you are taking a number C. A to C, and in between you are taking a number B, then integral, the total integral A to C f of x dx, this is actually equal to the integral from this to these two numbers, and then the integral from this to B to C, integral from A to B, integral from B to C, and that is a total. So you can always split like this, and you always have a choice. For example, if you look at the graph, and I'm saying that my graph is going from here to here, and I'm interested to look into the whole interval. If this whole interval, the whole interval is like this, and I split this whole interval into 3 parts. So you, even if you go from here to this number, or you go from here to here, and then from here to here, so both is the same thing. A whole is this, and if you split them, then you simply need to add these regions, the area under the curves. Just split this one, this part plus this part, and you will get the whole thing. So this is the same basic common sense scenario, but the rules work like this. And for example, if we have, we can use this rule here. If you have integral 0 to 10 f of x dx, and the answer for this integral is given to you, say 17, and there is another integral which is from 0 to 8 f of x dx, and the answer for this integral is given to you is 12, and you are asked to find integral from 8 to 10 f of x dx. So what will be the answer? So you have integral from 0 to 10, you have integral from 0 to 8, but the guy, you have these two data, but he is asking you to give only the integral from 8 to 10. You don't have that data from there, but you know the rule. Our rule was that integral from 0 to 10 f of x dx, if the mid number is 8. So what is your total interval? You can see the total interval is 0 to 10, and somewhere mid there is 8. So there are 3 points. So the rule says that you can always split the total into 2 parts. So you can go from 0 to 8. This total integral 0 to 10. This total, this is equal to integral from number 1 to 2. 0 to 8 f of x dx, plus then second number to third number, integral 8 to 10 f of x dx. Now in this formula you have generally written using the concept of that rule. Now in this formula, whatever values you have, put them here. For this integral you have a value, so it is 17, equals to, for this integral 0 to 8 you have a value, it is 12. But you don't have a value for this, so you will keep it 8 to 10 f of x dx. And this is what he asked you to find. So you can just switch them, 17 minus 12, so the answer is 5 for this, and using this data. So you can always build a relationship for the integrals if the numbers are in between the final endpoints. So whatever is the middle number, middle point, you can link them together like this. Eighth property says that if your function is a positive function, always greater than 0, the value is always greater than 0, means the curve of the function is always above this line. The curve will always be above this line if the answer for the function is a positive number. If for the function, if you get a negative number, then of course that curve will go somewhere below this line. So if you have the curve above the x-axis always, that is f of x is always positive, greater than 0, then the answer to the integral from a to b f of x dx using this function will also be greater than 0. Similarly, if you have, the ninth property says, if you have two functions such that f of x is greater than or equal to g of x, means there are two functions f of x and g of x such that this function is always greater than or equal to g of x. Less than property is not existing between them, then their integral will also hold the same property. Then integral a to b f of x dx will also be greater than or equal to integral a to b g of x dx. Same properties hold. And then if your function f of x is bound between two numbers, means the value of the function, for example, I am saying the value of the function is always contained in these 2 points. The minimum number m will be 13. The minimum of the value will always be 13. The function will never go on the left of this number, and the maximum of this function, whatever the value of x is, can be 100. Then in this case, the answer to this integral will be in between m into b minus a, and this will be less than or equal to integral f of x dx, and this will be less than or equal to capital M into b minus a, whatever the limits are. And do you know how to get this? We have studied a rule. The rule says, if you have this situation, if you apply integral on each side, so it will be integral m dx, integral f of x dx, integral capital M dx. What is m? This is a constant number, so it is just like c dx. less than or equal to what is f? F of x, this is a function, so I will keep it like this. And this is less than or equal to integral what is m? This is another constant. If this is c1, this is c2 dx. And I know the rules for these two. The rule says whatever this constant is, keep the limits from a to b. The formula says if you have this kind of integral, then it will be this constant into the upper limit minus the lower limit. This is less than or equal to this, I don't know, so it will be remain like this. And this is less than or equal to the same formula, this constant c into the upper limit minus the lower limit. But this c is small m, so I replace it. This c is capital M, so I replace it. So if you have this kind of situation, then your answer will always be contained in these two numbers. Whatever will be the answer of these two numbers, the derivative of this function, the integral of this function will always be in between these two. Now we are moving towards the fundamental theorem of calculus, and this is the theorem which has something to do with the concept of antiderivatives, which was studied by us in the last lecture of Advanced Mathematics 1.